Hello everyone. Today we have with us Zachary Jasper, who just finished his bachelor degree from University of Michigan, and he's also very interested in quantum chaos. So today we are going to ask him some questions and more about his interest. So hi Zachary, nice to meet you.
Hello, nice to meet you.
So, can you tell me, can we let's start from your school days and what was your favorite subjects? What were you interested in? And slowly, how your interest in this physics and then slowly in quantum chaos? How did it start?
Yeah. So from a young age, I was quite interested in mathematics. So mathematics was probably my initial movement into understanding physics, and then I quickly got interested in Einstein's theory of general relativity, and then I started moving in and trying to do the math. Thankfully, I was able to propel myself forward, and then I learned all about scientific things. So the application of math into real life became a very interesting thing to me, and I wanted to push the bounds and be as mathematical as possible. So what's the only way of doing that? Becoming a theoretical physicist working on quantum chaos.
What about being a mathematician?
Being a mathematician, you can do that too. The only issue is it's a lot more rigorous. You don't get to do all the fun hand wavy things that we're allowed to do in physics.
Yeah. Then what got you interested in chaos basically?
Yeah, so we were looking into problems associated with quantum information, and we started playing around with quantum information. You get this thing called circuit complexity, where you're in its own type of space, and in this space you have issues that can pop up. This comes in, and then you get from this quantum complexity, you can get into chaotic regimes. And we started looking into these specific regimes, and it just so happened that we found a problem that seemed quite interesting to us, very simple, and seemed to be very fruitful, that we decided to dive right into quantum chaos to see if we could do something interesting to make, well, not only quantum many-body physics more applicable, or maybe make it more distilled towards analytical solutions, but also to be able to apply it to systems like large strings of qubits, as we saw in our last talk that we listened to.
Can you tell us more about your days in University of Michigan? And how was the environment there? How was how did you basically enjoy there in Michigan?
Yeah. So I went to the University of Michigan Flint campus, which was specifically really good because the faculty to physics computer ratio was maybe 1-to-1. We were able to work very closely with our professors, and many of us were able to work on research from day one of coming into the university. We also were able to
so it's more research oriented,
and more learning oriented. So it was very common for students to work directly with professors to create new things. We had a couple students last semester actually create a frequency locked laser, which is very good. And they were going to make a laser cool setup, but that took a little too long, so they left that for someone else.
Okay. Can you tell us more about your current research with your supervisor? So what are you working on right now?
Yes. So we're working on a simplified spin 1/2 system. It's a single particle that we're just kicking with a magnetic field. And what we did was we tried to find a analytical solution, because for quantum many-body systems there aren't really analytical solutions. There's non-analytical numerical solutions that you don't really know what's going on. So you see these figures inside the numerics, and then you try to fit a curve to it. We want to do it the reverse way, and take it back from first principles and find interesting points, and then develop theories around those interesting points. So then we could somehow build up to larger systems.
And yesterday you were talking about ADS-CFT.
Yes.
So how are you going to apply this in your research, concept of holography and this stuff?
Yeah. So as of right now, with our current trajectory in this problem, I don't know if we specifically can, but we are looking at creating a very similar system, and then trying to calculate the transport coefficients.
Basically via holography. So
exactly.
It will be a holographic
like a mixed sizing model.
That's nice. So after your bachelor's, like you have did your bachelor's in University of Michigan. So what are your future plans, and like which field are you most interested in? Like you have worked in quantum information and quantum chaos. So what do you like to explore more now?
Yeah. So if I had to give a shot in the dark, the thing I like the most is just quantum chaos.
Okay.
Quantum information is great, and I love it. But I like the distillation of math. I like to be as mathematical as like close to the pure picture.
There's some kind of joy in when you're doing mathematics and
yeah. Well, when it comes to quantum information, sometimes you have this sensing error. You have this noise you have to approximate with.
Yeah.
It becomes very annoying in comparison. So if I could pick one, I'd probably stick in quantum complexity or quantum chaos. Although quantum information probably has more jobs in it, so I might go
Okay.
there.
I wish you all the best for like.
Thank you.
Thank you so much.